Welcome to East Academia. My name is Brian, and today we are going to talk about differentiation. And basically, this topic or this lesson is going to be basically about an introduction to what differentiation is. Of course, I'd introduce differentiation, don't mind the spellings. Of course, I'd introduce due to differentiation in the first lessons. But then at this stage, it is very important that you understand some definitions. Okay, so we shall cover some important definitions. So we shall cover definitions, and we shall cover terms, all right, terms. And I think maybe in our next video, we shall cover some various rules of differentiation. All right. So what exactly is differentiation? Differentiation is usually denoted as a rate of change, okay? Rate of change. As I said, it all depends on something changing at what rate compared to another, okay? So if we have an item X and another item Y, isn't it? Maybe X, I can say this is distance, right? Distance covered, isn't it? Distance covered. And then Y can be, let's say, time or something of that kind, or the other way around, right? In fact, it's best if I interchange them, okay? So let's say X now is time. X is time, and Y is distance covered, okay? So as time is progressing, you're also covering much distance, okay? So for instance, let's say you are from city A, okay? And you are from city A, and you are walking or you are moving towards city B. So I'll just have the city B here. So you are moving towards this city from A to B. So you are going to cover this distance, all right, at a particular time. So let's say you are going to take 2 hours here, isn't it, to cover let's say 4 kilometers, okay? So we want to see what is the rate at which the distance is changing with respect to time, isn't it? So let me say here it's y0 and here is y1, isn't it? And also the time that you left here was x0 and the time you arrived here is x1. So we want to see how this distance is changing with respect to time. So what you're going to do, we are going to get the difference, okay? We are going to get the final distance minus the initial distance, okay? So let's say this is 0 kilometers and here is 35 kilometers, yeah? All right? So final distance minus initial distance over the final time. Let's say you left here at 12:00 and you arrived here at 14:00. So you're going to get the final time minus the initial time, all right? So this, when you look at it the way it is, in mathematics we usually represent the final minus the initial time as a change, all right, because it is a change and it is denoted by this Greek symbol known as delta. So just a triangle. So for this one you can easily write this is delta y, okay? So this means that it is a change of in y, all right, which in essence it can the denominator can also be written as a change in x, all right, a change in x. So this is a Greek symbol delta, this one, all right. So now what it means then, what it means this way, it means that y is changing with respect to x, All right. Now, if you have to write it in terms of derivatives, all right, or a differentiation, you are going to write it the same way: the difference in y over the difference in x, dy dx. Okay, we don't say dy over dx, we say just dy dx, which this now is the rate of change, which this is the what we call is the rate of change. This is the differentiation now of y with respect to x. Differentiation of y with respect to x. So whatever is down here, that is with respect to whatever is down here. So the differentiation is taking place here with respect to what? With respect to x. So in essence, we are trying to look at how distance is changing as time is progressing. All right, or the rate at which this distance is changing, and the way the time is what is changing, because these two variables are both doing what? About changing. So how do they compare in terms of changing? All right. Now, in later lessons, which of course I'm going to teach as well, this one is going to be called a total derivative. Okay, a total derivative. But I think derivative, I'm just going to introduce now so that you know this is going to be a total derivative. Now, this one now is usually used in differentiating, especially a function that has one variable, all right, or so. But in some cases, you can have something that has several variables, but you only want to look at one particular variable. All right. So let us say something like temperature. I'll write temperature as T. Temperature is a function of, let me say, temperature. Is temperature a good example? Okay, let me say temperature is a function of the environment. I'll call environment E. It's also a function of the humidity, H, and it is the function of okay, let me just use these two. Let's say we have two variables, and this is just an arbitrary example. I'm not saying that temperature is a function of environment and humidity. Of course, humidity is inside the environment, but I am just going to use this as an example just to illustrate to you guys what a total derivative is and a partial derivative. Now, sometimes if you have a function t that is a function of two variables, which is environment and humidity, right? But you want to specifically check how this T or the temperature is changing with respect to the environment while holding humidity constant, you use what is known as a partial derivative. Partial derivative, okay? And this partial derivative is denoted, instead of having this dy over dx a straight one, now you're going to have a d which is curly, all right? So in this case, because we want to investigate the effect of temperature, okay, environment on temperature, then you're going to have dt with respect to dE, okay? So this means that you are holding what? You're holding H constant, the humidity. So we are only going to investigate the effects of what? The rate with respect to the environment. All right. Same thing. You can also, if you are given dt over dh, this one then means that you are checking the temperature with respect to humidity. Now, these ones, we are not going to cover them in this calculus one, all right? This one, we are going to cover them in a unit known as partial differential equations, okay? Differential equations, which is going to be covered later, PDEs. This is partial differential equations, which are PDEs. And but they use the same principles as these total derivatives. So it is best if you can understand how total derivatives occur, all right? And the concept of the rules of differentiation, everything just the same, all right? just the same. Now, coming back to this one, all right? Sometimes you do not want to write them as long as they are here, all right? So in essence, this one can also be abbreviated as y, all right, as y prime. I'm sorry, my pen just slipped. As y prime, all right? You guys should at least send me some money to buy good pens, okay? So y prime, all right? This means it's a first derivative. So this small dash on top of a function usually represents a rate of change. And now this derivative can be a first derivative, okay? So like this one, this means that we're differentiating once. So this is a first derivative. But then you can also have a situation whereby you are differentiating over and over again. So you're going to have different levels of derivatives, all right? So you can have a first derivative. So first derivatives, I'll just write here. So first derivatives, these ones are usually denoted as d. Let me just use dy over dx, which is also written as f prime of x, okay? But in this case, because the function is a function of y, you can just write it y prime of x, something of that kind. It will still give us the meaning, all right? So you can either write it with a prime or write it. Now, when you differentiate this first derivative, okay? Now you're not differentiating the function, you are differentiating the first derivative, again with respect to x. Then you get a second derivative. So it becomes this squared y over dx squared. So take note where we are putting that 2, all right? You can see the 2 is here, and in between d and y, and in this last one, it's outside, all right? Which this one is also written as f double prime of x, which can also be written as y prime of x, y double prime. You can get the third derivative also. So the third derivative, so this one can be 3, and y, okay, it can be, it's a function of x, y triple prime of x. You can also go ahead and get the fourth derivative. So this one is going to be f. In this case, you will shift from having these dashes, so you just write 4, all right? Which is equals y 4 of x, okay? And so forth and so forth. So this one progresses. Now from here 4, now it just proceeds with the f5 of x, f6 of x. These dashes, now you no longer use the dashes. All right, so basically that is what it means to have differentiation, and it is basically a rate of change, right? It's basically a rate of change. So for the example that we've had, if for example we have a change in distance over a change in time, okay, this is what is known as speed, all right? But if you're going to take the speed and differentiate it again with respect to time, you're going to assume you're going to get something that is known as acceleration. Okay? So while we want to say that speed, there's speed and there's acceleration, realize that speed is a first derivative, acceleration is a second derivative. But all of them talk about rates of change. So those are the basic things that you need to know in differentiation. Yeah, and there are various techniques of differentiating. You can have a power rule, which you're going to talk about them. We have power rule. All right, you're going to talk about chain rule. I will begin with these ones before we introduce the L'Hopital's rule, because these are the things that we will employ, because the L'Hopital rules definitely uses differentiation to evaluate limits. And that's why I thought it is important that we really cover this lesson and talk about derivatives first before we proceed to power rule and chain rule and all other rules. We have product rule, we have quotient rule, we have the difference rule, but we shall cover all these and see how they are affecting differentiation at different stages. All right. Now, so if you are told to find, so sometimes you can just told to find dy over dx of a certain function. This means first you find the first derivative, right? This means you find the first derivative. If it's d squared y over dx squared, then second derivative, and so forth and so forth. So you really have to be keen and careful as to what you are doing and to know what exactly is there. So we will deal with total derivatives as of now. And this delta, this one is important. Remember, it is the final minus, it will always be final minus initial. So take note of that. Don't take initial minus final, or rather the way around. It is final minus initial. So this one, just keep note. Final minus initial, final minus initial. So that one, and even as we proceed with this course, we are able to know, we will be able to know what exactly goes where. So this course basically is going to give you a very good meaning of differentiation, but for now I'm going to cover in the next lesson power rule differentiation, and I will also make another lesson for chain rule differentiation so that we are able to evaluate those limits using L'Hopital's rule, which I think that one will be our last method. Although I'm going to show you another method, but this one will mostly working it in the in a website. I'm going to provide a website that is going to evaluate for you limits. So thank you guys, and meet you in the next video. And I hope this video is helpful. And if it was, remember to subscribe, like, and share. So thank you and have a nice time.